I want to know what the mass of, let's say, Mg. Mg, what is the mass of Mg? 24 what? We're gonna stick grams on the back of it, 24 grams. Okay. What if I asked you for the mass of Al? What's the mass of Al?
27.
It's gonna be 27 grams. You're getting that off the periodic table. What if I had Al2? How would you calculate this? I want the mass. Now, when I say mass, I can say molar mass, I can say formula mass. Okay, but what do you do?
Multiply by 2.
Okay, so you do 2 times what? 27 grams equals 54 grams. Okay, I'm going to give you another one. What if I give you something like NaOH? What do I need to do? All right. How many sodiums do I have? How many sodiums do I have here?
1.
What's the mass of it? 23 grams. How many oxygens do I have?
1.
What's the mass?
16.
How many hydrogens do I have?
1.
Mass.
1.
What do I do with those numbers? You're going to add them up. So this would be 40? 9, 40. 9, 10, 2, 3, 4, 40 grams. Okay? Okay, questions on those? All right. So, on your paper here, you have calculate the formula mass of carbon dioxide, CO2. Okay, so what are you going to do? We need to break this up, break up your list. We have C. How many C's do we have?
1.
Okay, so I have 1, and the mass is?
12 grams.
Okay, so I have 12 grams. And then I have O. How many O's do I have?
2.
Look at the number after it. There's 2. And you have a mass of that? 16 grams. So 2 times 16 equals? Okay, you're going to add those up. So your answer will be what? 44 grams. That is the molar mass. That is the formula mass for CO2. Okay, questions? All right, I'm going to give you a couple other things. Hold on. No. You have those? All right, let's go back and I want to show you something else. Now, what if I give you something like this? What are you going to do with that one? First off, you're going to make your list. What do I have? I have CAs. What else do I have here? N's. What else do I have? O. Okay, now, how many CAs do I have? 1. And what's the mass of the CA? 40 grams. Okay, now, here's the thing about parentheses. You have the parentheses here, and you have a number, a subscript that's on the outside. The number that is on the outside gets multiplied by everything that is on the inside. So that means what happens is I have, on the inside, how many N's do I have here?
1.
That's 1, but it's 1 times 2 is? 2. Okay, 2. My oxygen, here it says 3, but it's 3 times 2, so it would be?
6.
Okay, so 6 times 16. 2 times, what's nitrogen? 14 grams. Okay, so I have 40 grams plus 28 grams plus 96. 96 grams equals 4, 13, 14, 15, 16, 164 grams. Okay, what you can do is write a couple of these examples on that page 44 in your notebook. Because remember, your notes are going to flip up, right? So you can write on the page of your notebook. Write them down. Page 44. Page 44. Write down a couple of the examples. I'm going to give you one more to try in your notebook. Go ahead and write down a couple of those. Write down some examples right there. Yeah, the examples that I just put up on the board. Write down in your notebook. Looking for something I'm not seeing. Where is your? Let me see your notebook. Try this one. All right, try that one. So first thing we do, separate them, make your list. So we have ALs, what do we have? Okay, so remember, when you're trying to figure out, one of the questions that came up was how do you tell which letters go together for an element and which ones don't? Capital and lowercase. If there's a lowercase letter, it goes with the capital that was before it, all right? If you see a capital and followed by another capital, those are two different elements, okay? So I have AL, and what else do I have here? CR, and then? O. Okay, so AL, how many are there?
2.
CRs, how many?
2. No,
2 in here, but it's in parentheses.
6.
2 times, right, okay, 6. And oxygen?
21.
There's 21. 21. Okay, aluminum is what? Mass? 27. And what about your CR?
52.
52. All right. And this is why you need calculators. So go ahead and get those numbers and add them up to get your final value. Calculators are up there. You can borrow. Get them as soon as you come in the classroom. From now on, just put them back before you leave. Okay, so remember, questions can be asking you about mass, can be asking you for formula mass, can be asking you about your molar mass. All right, so that's how you're going to solve it. Okay, so as far as the molar mass part that you did, ladies and gentlemen, the way that you're doing it in your notes right now, the practice, make sure you do it in your assignment that way, because if you don't, then you will not get credit for it. Okay, so please make sure it's in the right format. The right format means it's easy for me to follow your work. So even on a quiz or a test, make sure you do it that way, because if I can follow your work, if something is wrong, let's say that you had it all set up correctly and you got the wrong answer, I can still give you partial credit because I can see that you know how to do the work. But if you're all willy-nilly all over the place, I can't give you credit because I can't follow it. I'm not going to try to figure it out. All right? So please make sure the format that I'm telling you to do it in is the way that you do it in your assignment. Okay, so you were just working on molar mass. Again, it can say molar mass. You can just be saying solve for the mass. It could be asking for the formula mass. It's still solving for the mass. So as far as this, what you're looking at this part right here. So molar mass is in grams. So on this chart, when you see this part here, molar mass, that means you need to go to your periodic table, break up your compound into the different elements and atoms, okay, and then come up with a specific number here. Okay, so what we're going to be doing is we're going to be looking at this in terms of calculating or converting moles or to different areas on this chart, all right? Now here, what I was saying is that 6.02 times 10 to the 23rd is the number associated with the mole, but it doesn't matter what you put on the back of it. So it's the same as if I say a pair, shoes, pair of turkeys, pair of hams, pair of whatever, doesn't matter what I'm talking about, the number is still 2. So whenever you see the word, if they're asking you about atoms or particles or formula units, molecules, the number that you're going to put in front of that word is going to be 6.02 times 10 to the 23rd. Okay, so what I need you to do is go ahead and write that on your paper, on your charts. And we're going to work on using this chart. So you're looking at conversions, lots of conversions today in the next class, and for the rest of the semester, basically. This chart, when you get finished with this and when we're done for today, this is the chart that you're going to glue down in the space where it says diagram. Just do it as an extender or glue it into that spot. Not right now, after we're done. Anyone still need this? Raise your hand if you need it. Okay, so go to the back of your notes. We're going to start with some of the conversions. Okay, so when you are setting up your notebook, I'll put my notebook up here in a little bit so you can see how the page is set up, but in your notebook page, you are not going to do your work on the handout that I gave you. You're going to do it on your notebook page, and what you're going to do is you're going to split it. So you're going to actually draw a line down the side of your paper. Okay, on page 45, it's going to be split like this. You're going to make a list over here, and you show all your work and box your answer on this side. We're going to use your notes in the same format. So this side is going to be your column. This is where your list is going to go, is underneath here. And then you're going to show, so list is going to go here, over on this side, and then you show all your work over on this side. Okay, so are there any questions on that? All right, so let's look at, where is it? Let's start with the first one. All right, converting moles to grams. Okay, so one thing I want you to get used to, you're going to make a list because you need to get comfortable with going through a bunch of information. Okay, pick out what you need. What am I looking for? And what do I need to solve it? One of the problems that I saw with the unit exam that we took is that some of the questions were really simple, but you had to read a paragraph of information before. Okay? And I think some of the students, what happened was you got lost in all the extra stuff that was written, all right? It all boiled down to what's the stuff, what were the things that you saw in an equation that let you know if it was like a nuclear reaction? What kind of things were you looking for? As far as an equation's written out, how do you know it's a nuclear reaction? There was alpha decay, there was what? Beta decay, there was, you were looking for those types of things. If you saw it, it was a nuclear reaction, okay? Does anyone remember why is it that in making bombs, it's better to use a nuclear reaction, things that happen in a nuclear reaction instead of just a regular chemical reaction. Why would you want it in a bomb? Which one has produces the bigger amount of energy? The nuclear or chemical? Nuclear. And do you need a big mass or small mass is good? That's it. Small mass produces a large amount of energy. Makes it perfect for bombs. All right. And you had questions like that were on tests. But then what happened was you had a whole paragraph of information about the history of the bombs, and this is the equation that they were using, and blah, 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 just a whole bunch of stuff. And then they asked you, well, why would they want to use this? Y'all just gave me the answer, but then you picked something else on the test. Okay? Probably because you were looking through that paragraph and trying to find the answer in that. So it's not like an English test where you were reading a paragraph and then you go back to find the answer in there. That's not how this works, all right? I will tell you that a lot of the tests, and the way we're doing it is because we see this on a lot of tests that the state gives, all right? They are called detractors. They are purposeful distractions. It's put there to see if you can figure out what I need to ignore. What is it that I need to do? I need to ignore all this, and I'm just looking for, this is the information I need to answer my question, all right? So try not to get lost in the paragraph. If you're given a paragraph for these kind of questions, simply, what are you looking for? What am I looking for? What do I need to solve it? Ignore everything else, okay? All right, so for this one, so on the side, what you're gonna do, your column to the left, you're gonna have your given, and then you're gonna have your question. Your question is what you're looking for. So the question is, how many grams of lithium are in 3.5 moles of lithium? What am I given to actually work with? What number am I given?
3.59.
Okay, so I'm going to write 3.5 mole, MOL is the abbreviation for moles of lithium. So I have 3.50 moles of lithium. What am I looking for?
Grams.
Grams of lithium. So this is the way you're going to set it up in your homework. Make sure you have your two columns. Okay, so now we go to the chart. I'm going to look at the chart. And what I'm looking for is where am I starting from? So what am I given? And what am I looking for? So where on this is, I have 3.5 moles of lithium. Where is moles on this chart? Where is moles on this chart?
2.
Then the one that's labeled number 2. Okay, so it's this one. Where is grams on this chart?
1 at the top.
It's at the top here. Okay, so what happens is I see there is one line connecting them, right? So that means this is only a one-step problem. Okay? If you see one line connecting them, then I'm going to have one line in my problem. You start with your given. So the first thing I write out is my given. 3.50 moles of lithium. And then, how many lines did we say? We have one line, that's one step. For every step you have to take, you're going to do times in a line, times in a line, times in a line. You do one line for every step. This is a one step, so I only need one line. One step, one line. 2 steps, how many lines?
2.
2. Okay, so this is a one step. Now, when you look at this, I see moles on top. You want to look at this as a fraction. So if I wrote 3.5 as a fraction, it would be, what would it look like? 3.5 over what? 1. So this is like this whole thing is over 1, which means moles is in the top, right? It's in the numerator. If I want it to cancel out, I'm multiplying it by something over here. If I want moles to cancel out, I need it to either write it on top or bottom. Where would I write it for it to cancel out? So that would be like, you write it at the bottom because that's mole divided by mole is equal to what? 3 divided by 3 is what? So mole divided by mole is, okay, so that's how we're in a sense canceling it out. We're getting rid of the unit, all right? So mole goes on the bottom. Follow your chart. So we start at moles, and we are going to grams, right? So grams, and that's what I'm looking for. Grams is going to go on top. The stuff that is on the line tells you what's supposed to go, on the line. Okay, so what number goes in front of mole? 1. It doesn't matter if it's on top or bottom, okay? You set it up like it needs to be set up, but whatever the setup does, mole can be on top, mole can be on bottom, but always the number that goes in front of mole is going to be a 1. And the other part where it says grams is in grams. Where do I get that information?
The molar mass.
Molar mass. And how do I figure out the molar mass?
Periodic table.
You go to the periodic table. All right, so we said 1 goes in front of the mole. There's mole. 1 goes here. So what's the mass? What's the molar mass of lithium? 7. So what I have here is moles cancel out, mole divided by mole cancels out, and I am left with 3.5 times 7. Okay, so go ahead and put that in your calculator. See what the answer is. 3.50, 3.5, same thing, times 7. What do you need to do? 24.5. You're multiplying them together. Everything in the top gets multiplied together. 24.5, and we are left with grams of lithium. Box your answer.
Did you round it to the whole number? Or?
Excuse me? Round it up to 1 decimal place or 2 decimal places. Is that what you're asking? Okay. If you have a long bunch of numbers that follow after the decimal, round it off to 2 decimal places. All right. Make your list for the next one. Make your list for this one. How many moles of lithium are in 18.2 grams of lithium? Make your list first. What you're given?
18.2 grams.
Good, 18.2 grams. And then what am I looking for? Moles. Okay, so I'm always going to start by, if my problem is going to start by writing down what I'm given to work with. So I have 18.2 grams of lithium to work with. Go to the chart. We need to go from grams to moles. Grams to moles. Where's grams?
The top.
Moles is
I think that's 2.
how many steps?
1.
1 line, 1 step. All right. Grams is on top. So where does it go on the line, top or bottom?
Bottom. Top.
Grams is on top already. We need it to cancel out.
Bottom.
Bottom, because if I go gram times gram, this is going to make gram squared. Gram divided by gram will cancel out. And then we were going from grams to
Moles.
mole, so mole goes on top. What number goes in front of mole?
1.
1. Where do we get that number? Where do we get the number? You said 1 goes in front of the mole. Where are you getting that from? From the chart. Okay, so it says for here's my 1 line. 1 goes in front of the mole. Okay, and then I need the molar mass.
7.
It's 7. Still working with lithium. Okay, in this case, 18.2 is on top and 7 is on the bottom. That means 18.2 divided by 7. Grams will cancel out. It's what? 2.6 units. What am I left with? Moles of lithium. Remember, MOL is the abbreviation for moles, not molecules. There's no abbreviation for molecules. Questions on this one? Okay, go ahead and start the next one. See how far you can get. All right. Where are we starting?
3.5.
Okay, so my given is moles is where on this chart? Where is it on here? It's number 2. And I'm going where?
To the middle.
What am I looking for?
Molecules. Or
I'm looking for atoms. Where's atoms?
molecules.
The one that says molecules. So molecules are particles or atoms, formula units, all of it's over here. So we're how many steps?
1.
You have 1 step. So 1 step. Mole goes where? On the bottom. And what are we converting to? Atoms. So atoms goes on top. Okay, so looking at these numbers here that are on the line, what number goes in front of mole?
1.
Okay, so and what number goes in front of atoms?
6.02 times 22.
Good. So remember, this is molecules, particles, atoms, formula units. You're going to put that number 6.02 times 10 to the 23rd in front of it. Okay. Now, hold on. You are dealing with exponents and you're putting this in the calculator. Okay, so this part right here with the times 10 to the 23rd, do not, I repeat, do not type in a times and a 10. You will not get the right answer. Okay, there it's an exponent. You're dealing with exponents, so you need to use an exponent button. Okay, so I'm going to write down here specific steps on how to use it. Write it down because you need to make sure that you can do this on your own and not asking how to use your calculator. If you have the TIs, okay, so when I'm typing this number in, this is what I'm going to type in. I'm going to type in 3.5 or 3.50 times, I'm going to type in the 6.02. The times 10 part, you are looking for a button on your calculator. Now, if you have the Casio, the ones who have the Casios, look down on the bottom and you see a button that says EXP. That's your exponent button. That is your times 10. So instead of hitting times 10, you're going to be using the exponent button. I don't hit, there's no 10, no times. And then you're going to type your 23. So this is 6.02 times 10 to the 23rd equals, you get your answer. If you have the TI, the ones in the class, you are going to hit the 6.02, so you're still going to do 3.50 times 6.02, but you're looking for a button that says EE. There's an EE button. And it's not a button in itself, it is, yeah, you're looking for, it's the blue. You see the second key? So one here, right here, it's the X to the negative 1, you see the EE is above it, right? So that means you're going to have to hit the second key. So you're going to go 6.02, second key, EE, and it'll give you just an E on the screen, and then 23 equals. Now, if your answer comes out with an E in it, you're not going to write E as far as your answer. You're going to put the times 10 back in when you write out your number. Does anyone have a different calculator they need help with? I have a Casio, but mine, I'm using a Casio. Mine is a Casio. It's got a different button on it. Does anyone else have another calculator? All right. So we have 3.5. Okay, what answer did you get? Answer?
2.107 times 10 to the 20.
Okay, we're going to round this off to 2 decimal places. This is 2.1 what?
1.
2.11 times 10 to the 24th. Your moles canceled out. You were left with atoms. Okay, last one. Go ahead and set it up.
Genius. You're not. I know, but
Set up your last one. set up your last one. Anyone notice anything? It's a two-step. Okay. Because you're starting from what? You're starting from grams. They give you grams and you're going where?
To moles.
So you got to go from grams to moles, and finally, ultimately what are you looking for? Are you looking for molecules? Atoms. Okay. Use the correct terms. Okay, so you got to go grams to moles and moles to atoms. So 2 lines. 2 steps, 2 lines. All right, so our first line. Grams is on top. Where does it go here?
Grams at the bottom.
Grams on the bottom, and follow the chart. You're going from grams to moles. So moles goes on top of that one. What number goes in front of moles?
1.
And what number goes in front of grams? It's still lithium, so 7 molar mass of that. Okay, your grams will cancel out. You are on moles. So now this is like our new given. Moles on top here. Where does it go on the second line? Bottom. And we're going from moles to atoms. Good. Number in front of moles?
6.1.
Number in front of moles? 1. And number in front of atoms?
6.02 times 10 to 23.
Moles will cancel out and you'll be left with atoms. Okay. Now, you have stuff on top that is going to get multiplied together to get an answer. And then you need to divide by everything that's on the bottom. In this case, we only have 7. So, type it into your calculator. Do your 18.2 times your 6.02. Exponent button. 23. Get an answer. Get your answer. Equals, you're going to get an answer. Whatever pops up in the calculator, we're not done. What do we need to do?
What about the 7?
Hold on, that's what we're talking about. So we only did the stuff on top. Get an answer. What do you do with the stuff on bottom? So once you get an answer, hit divide by 7 to get your final answer. I think I heard the answer is 1 point what? 57, 1.57 times 10 to the what? 24, good. And that's atoms of lithium. Box your answer. Okay, all right, so the last thing that we needed to work on in this, we worked on going from moles to grams or grams to moles. We did molecules, atoms, something to moles, or vice versa. Remember that whichever way you're going to be using the information that is here is going to go on your line for the conversions. All right, the last thing that we have is for working from moles to volume, which volume is going to be measured in your liters. Okay, so the first problem we have here is how many moles of hydrogen are in 100 liters of hydrogen at STP. Okay, so when you see this right here, it says STP. Does everyone see that? STP? Do not worry about that right now. STP just means standard temperature and pressure. There are specific numbers. There is a standard temperature and there's a standard pressure. You don't need that information for these types of problems. You will need it next semester. All right, I will give you those numbers next semester, but for these types of problems, it's not mattering. Okay, the only thing that it's telling you is that it is a standard. There's a set temperature and there's a set pressure, which this is happening. but you don't need it for these problems, okay? Are there any questions on that? So STP is not important for this. We still do it the same way. So we have, you're going to make your list. So what is your given? It's what? 100 liters of hydrogen. Okay, now, when you see hydrogen, this is going to be important though. This is hydrogen. And hydrogen is one of those things that we had mentioned before, I had mentioned before, called a diatomic molecule. All right? Hydrogen, along with a few other elements, cannot exist as a single atom in nature. They have to be connected to something. So if it's not already connected to something like water, hydrogen's connected to what?
Water.
What is the formula, chemical formula for water? H2O. So H is not by itself. I don't have just a single atom of hydrogen floating around, right? It's already attached to something else. So there are certain ones that have to have something attached to them. So if you just hear their name like hydrogen, well, I know hydrogen can't exist as a single atom. It's got to exist as, at minimum, a diatomic molecule. So when you see hydrogen, that means this is not H, all right? It cannot exist alone. It's not a single atom. This is actually H2. So when you write this, this is 100 liters. 100 liters of hydrogen is H2. Make sure you put the H2 on there and don't use it just as H. Because if they ask you to do the mass, if you don't have one atom, then you have 1 gram. But this is actually 2 atoms, which means your mass would be what? 2 grams. All right, so it's really important that you have that. Okay, so what I am going to do is down here in the bottom of your notes, what I would like you to do right now, and I'll give you a sheet later on, but there are certain ones, like I said, that cannot exist by themselves. So these are called your diatomic molecules. And we actually covered a few of them when we were doing the covalent bonds. Does anyone remember the ones that had like a 2 on the end of them? So H2 is 1. We had, what did we work with? No, we didn't have a C2. We had a Cl2, chlorine 2, Cl2, what else? Okay, not H2O. Something bonded directly to another atom of itself. Same kind of atom, and there's only 2 of them put together. So we had Cl2, we had F2. Does anyone remember those from their notes when we did covalent bonding? Single bond, triple bond, the double bond. Okay, we have Cl2, F2, N2, O2, Br2, 1, 2, 3, 4, 5, Br2, and I2. Okay, I want you to take a look at the periodic table. If I was to ask you to name the diatomic molecules, look at where H is. You see H? So H is over to the left all by itself. Okay, look at over at atomic number 7. What is that? Okay, now look at, follow where I'm going. N2, O2, F2, Cl2, Br2, I2. Do you see a pattern? Okay, so remember, helpful. Okay, if you don't remember, look for patterns. So hydrogen's over there by its lonesome, but then we have nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. It forms like a 7, or you can look at it as an upside down L. Does everyone see that? Okay, so keep that in mind. It goes, look at where N is, atomic number 7, to O and F. Now go down, Cl, Br, I. So anytime you see those names, automatically, unless it's already joined to something else, automatically put a 2 at the end, all right? Right, so that is 100 liters of H2, and then what's my question? What am I looking for? Looking for moles of what? Moles of hydrogen. Okay, I'm going to start by writing my given. Okay, and it says I'm going from liters to moles. If you look at your chart, we have, here's liters here, that's a volume, to moles. How many steps do I see? 1 step, 1 line. Liters is on top. Where does it go on the line? Liters is on top here. Where does it go? Bottom. And why do I want it on the bottom? To cancel it out. Okay, so this looks like I go liters. So what's going to be above it? Moles on top. Looking at your conversion right here, what number goes in front of moles
1,
and what number goes in front of liters?
2.4.
All right. So this is 100 times 1 divided by 22.4. So 100 divided by 22.4. Did y'all get your calculators? Math all day. At least this period.
Uh,
100 divided by 22.4, what is it? 4.46. What units am I left with? Liters canceled out. What units am I left with? Moles of H2. And make sure to box your answer. So remember, your homework has to be set up this way. Same thing but for the quiz. Let's try the last one. Questions on that one? I'm sorry, question? Okay. Questions on this one, anyone? Okay, look at the next one. How many liters are occupied by 3 moles of oxygen gas at STP? All right, what is my given? Of what? And how do I write oxygen? O2. O2, it's a diatomic, thank you. O2, question. Memorize that list. What are you looking for? All right, go ahead and set it up, work it out.